Okay, this is the beginning of the operation. If you can look at this one station as it exists, it's approximately 2.5 feet, 3 feet wide. This is 3 different work areas that existed within the current state map that you saw. This would equate to approximately, in real estate terms, probably about 30 to 40 square foot of production space prior, now down to about 3 square feet. What we did is we took our brazing operation and some of our cleaning operation and some of our rinsing operation, which involved deionized water, in 3 different areas of the plant and put them together where they actually need to combine. We simplified that process from what would have been 5 minutes of labor and probably 10 minutes of travel time to 0 travel time and probably about 2 minutes of labor. This is probably the piece de resistance in terms of the overall operation, but we've taken all the concepts here and put them throughout. So I'll walk you through the process quickly. This is the cleaning and brazing area, as I mentioned. What we have here, we have a torch, which is auto on, no more lighting it every time that you go to use it. It's here, it's at hand. The operator doesn't have to worry about the flame or the flame controls as they used to, so it's safer. We created a solid copper block to extract the heat when we're welding stems on. It's actually a brazing technique. This block absorbs the heat, so you do not get this level of discoloration anymore. It will be a reduced level of discoloration with an improved adhesion of the stems, which will fit in as such and are brazed into place. The best part of this station is that it's mixed model. As you saw, it worked for the large 366C pan, it works for the smaller pan. Or it works for the smaller pan. This station is not required for the flow detectors, but the flow detectors are also integrated into this overall concept, and they start at the next station. So what we've done here is taken mixed model, which is a number of different detectors, different types, including flow detectors as well as seal detectors, and integrated all of the manufacturing techniques so that they would flow and process. To run you through very quickly, it also, this is the welding station or brazing station. This is the pan cleaning station. We then apply automatically some epoxy feed-throughs, and this is through new dispensers hooked up to automated tools with dedicated tooling, ergonomically placed and very light and easy to control. We have point-of-use inventory at the required place. So for feed-throughs, for screws, they're all currently right there. These will be on a Kanban system, and when it comes to replenishment of material such as this, the concept of these feeders is that there will be a golf ball which will indicate that behind that golf ball there is approximately 1 day or 2 days worth of supply of inventory, and that there will be a card to hand in to replenish that inventory. In effect, a Kanban system for inventory replenishment. So the inventory is dedicated. This is where we apply epoxy. It goes in the oven and gets cured. And here we apply the anodes. The anode wire is dedicated right here. And then we apply the film, and this could be either mylar or titanium. Currently we mainly do mylar, but it's capable of both. We apply the screening windows. They're all right here again. As well as another application of epoxy, and that epoxy goes on the window. There's a timer that's set because it's critical within this oven. This is an industrial grade oven, and it controls the temperature much more carefully than the other oven. The reason for this is because the mylar will melt at a certain temperature, so we have to maintain levels of control. Here's where we enter our first curtain operations. This is where we create a batch of materials within containers. These batches are outgoing, where they become pumped on a pumping station outside of this operation. There's an exchange at that operation. So there's incoming goods. When these go out, a cart is brought back with goods that are completed in that operation. And that's helium testing for the first level. There's a secondary curtain operation which involves materials which are finished the helium testing. Once they pass that, then they will be tested here, and that's in development. Once they're tested in their initial testing, they will be tagged with their appropriate results, as these are, and they will go out for aging. When they come back from aging, again, this is another curtain operation where the 16 units go out, they go for aging, they come back, they get retested against results. When they're retested, if those results are mirror imaged, if these results are mirror imaged, then the detector is determined to be a viable good, and it is considered finished goods at that point. It's at that point we finish up the operation with deconnectors, with labels, and general assembly into casings, etc. so forth. Each station has a takt time of 29 minutes. So roughly in the process, as somebody walks through, that means that operationally we will be able to sweep through here in 29 minutes to produce one detector.